So today, I have a couple of topics to discuss. The first one I really want to talk about is about polygons. Yes, polygon. A polygon consists of, could be like that. Okay, this is called a polygon. And then you can talk about interior angle and exterior angle. So let's go over the what we learned before. So you rotate counterclockwise. You define the exterior angle in the following way. Okay, this goes like that. Okay, this is we call beta 1, beta 2, and sometimes its exterior angle is larger than 90 degrees. Some are smaller than 90 degrees. Okay, so you have to find a way how to rotate to define this exterior angles. And it's interesting to know that the sum of exterior angle is always going to be 360 degrees. Okay, it doesn't matter how many edges do you have. But if you look at the interior angle, okay, the interior angle will be different. The sum of interior angle is 180 degrees times n minus 2. Okay, so there's a difference between them. Okay. For example, you look at the triangle. Triangle is a special polygon, right? Triangle here, just use alpha and beta and the gamma. So alpha plus beta plus gamma, it's 180 degrees times 3 minus 2, which is 1. So it's 180 degrees. Okay, Kellen, sit here. Okay. So this is a special, right? But if you're talking about the exterior angle, and it will be always a 360 degrees. Let's do this. We can find the exterior angle directly. That's called alpha prime, beta prime, gamma prime, right? So exterior angle is going to be 180 degrees minus alpha plus 180 degrees minus alpha, beta, and plus 180 degrees minus gamma. And you will see that you get 3 times 180 degrees minus alpha minus beta minus gamma. So this is 180 degrees. So the final answer will be, this is 180 degrees. So it's going to be 180 degrees times 2, 360 degrees. And after you did several problems, you find out it's the sum of exterior angle is always equal to 360 degrees. It's independent of the dimension. Independent of the edge lenses. Now, the so-called regular polygon. Regular polygon means all the angles are the same. Okay, that looks like perfect. Yeah, all the angles are the same. Okay, all the angles. So beta 1 equals beta 2. They're all equal, the same angle. Okay, it's beta. Then alpha 1, this is alpha 1, right? This is beta. So they're all the same. Now, if this is n polygon, okay, can we figure out n? Well, n times beta should be equal to 360 degrees. So beta is going to be 360 degrees by n, okay? If we use an interior angle, n times alpha, which is the sum of n interior angle, is going to be 180 degrees, n minus 2. So how do you figure out alpha, which is going to be divided by n. Okay, so more edges it, of course, this is going to be decreased, right? The interior angle will be decreased. But it's getting close to 180 degree. See, you see that, right? This is going to be 180 degree, 1 minus 2 over n. It's a limit case. The reason is more edges you add, the interior angle is really getting close to 180 degree when n getting larger. But for the exterior angle, clearly, when n is getting large, and that is going to be getting smaller. You see, look at this, right? So if more edges of a polygon, then the exterior angle is getting smaller, right? And eventually collapse to 0. But then the interior angle will be getting close to 180 degrees because more flat. All right. So our question is, okay, if you know two polygons, okay, we just compare two regular polygons, okay? One has n edges, okay, and n sides. Another one the m sides, okay? So the exterior angle, remember the exterior angle in this case, this is just polygon, right? So let's draw the picture, okay? So the exterior angle, this one is going to be 360 degree divided by n, exterior angle, okay? And this will be 360 divided by m. Now, question is, if the second one has 45 degree more than the first one, okay? Does this become an algebraic problem? What is the largest possible value of m? I think, hold on, See, look at this problem. Which should be larger? I think m is going to be smaller than here. Otherwise, it's not large, right? M is smaller than n. So that's why the exterior angle here is larger than the exterior angle there, because you have a, you have a small, right? The denominator, look at, right? So this is the exterior angle, okay? So it becomes number theory problem here. It's really nothing to do with geometry as long as you write down this identity, okay? So what are the possible values? How do we solve it? Okay, you can solve for. It depends on how you do it, right? You want to find the largest possible value for n or largest possible value for m. Let me see. I'm going to find the largest possible value for n. Yeah, it's this is a problem from the last homework problem. I don't know which one is m, which one is m. Okay, let me double check. Yeah. Okay. M should be N should be larger. I'm doing the opposite way right now. That's okay. Yeah, this is what is the largest possible value for N? Let's look at this one first. Okay. So here this, largest possible value M. So what you should do? Well, you have to simplify a little bit, right? Solve for N. That's my suggestion. So solve for N. 360 degree m minus 45 degree, right? But actually, you can divide both sides by 15 if you want to simplify a little bit, because every term contains 15 there. If you divide by 15, that's simplifying a little bit. So 24 over n divided by 15 degrees, then degree is gone, right? 24m minus 3. Okay. Yeah, minus 3. Then 24 minus 3m divided by m. Okay. Then you divide, turn this upside down, right? This must be positive. So 1 over n is going to be 24m, 24 minus 3m. Then you solve for n. All right, there are not many choices for m here because this should be positive. Then you look at the possible value for m. M could be, no, m cannot be 1, right? Because this is a polygon. The smallest value for m is 3, right? 4, 5, 6, 7, right? I think it cannot be 8. At least look at the expression. 3m should be less than 24, right? So you stop there. That's a possible value for m. So then you look at which one gives the integer, because this must be integer. N must be integer. Is an integer, right? And also greater than equal to 3. Otherwise, this is wrong, right? It's the integer. Then you look at each case, right? So when m equals 3, so let's say n equals 24 times 3, 24 minus 9. Okay, I can cancel 3, and this is now going to be integer, divided by 3. And this is not going to be integer. 24 divided by 5 is not going to be integer. It's wrong. Okay, it's not integer, right? Then m equals 4. 24 times 4. 24 times minus 3 times 4. So I think we can get rid of 4, right? 24. 24 is 4 times 6. 6 minus 3, right? Okay. 6 minus 3 is 3. 24 divided by 3. Okay. 8. Okay. So this is possible. This is already given in the example. Okay. So m equals 5. When m equals 5, let's see. Let's take a quick look. Computation. 24 minus 3 times 5. I don't think it's divisible because 24 minus 15. It's gonna be 9. 9 is a 24 is not divisible by 9, so you cancel it out. So m, there's just few of them, right? 24 times 6, 24 minus 3 times 6. Okay. So this will be 4 times 6, right? 6 canceled out. So that's just 24. So n is going to be 24. That's the one. Then the last one, I don't think it's going to be solution. It's 24 times 7. 24 minus 3 times 7. Oh, that's still possible solution. It's 24 minus 21, 3. So that is going to be 8. So 56. So it looks like 56 is the largest possibility for n, right? So you have 3 solutions, 3 sets of polygons, 3 pairs of polygons satisfying the required equation. Okay, satisfying equations 4 and 8, and 6 and 24, and 7 and 56. Okay, so they're all possible, right? So the answer is the largest possible value for n is 56. Okay, since 56 is indeed the largest possible value. So it's become an algebraic a number theory problems. Okay, we okay. There are similar type of equations in other problems, not necessarily geometry problem. Just you have equations, find the yeah, if you have a relationship between two integers, find the possible solutions. Okay, then you have to make sure both are integers and both are positives. Okay, for example, yeah, find all pairs of positive integers n m. They are satisfying the following equation. Okay, so for example, the equation 2m plus 3m equals 27, something like that. Okay, so if you have equations, maybe you can find a solution, maybe you cannot, right? So let's see how many solutions you can get. It's very similar to the above problem. You can solve for n, you can solve for m, okay, in terms of variables. So let's try to use, yeah, let's just solve for n. That's 27 minus 3m, right? And that's a little bit easier problem because I only have one m here, right? So n equals 27 minus 3m divided by 2. Then you just list all the possible values so you can make sure. All right, so when you look at this, you should, so first of all, you see that possible value for n is going to be, right, it's going to be 1, 2, and I think the last one is not going to be, it's going to be 8, first of all, right? Because if m is 9, you get 0. You have to make sure n is positive. But by simple computation, you want to make sure this is an integer, right? If this is integer, the numerator must be even. In order to make sure the numerator is even, m cannot be odd, because 3 times other number is odd, then the difference will be even. So m must be even. So that's the first thing. Second is because m must be okay, must be an odd number. Okay, otherwise the numerator cannot be even, because if m is even, then odd minus even is odd. Odd divided by 2 is odd. It's not going to be integer. So immediately you conclude that m is going to be 1, 3, 5, 7. So you only have 4 choices. Then you check which one gives you a good answers, right? So when m equals 1, so n equals 27 minus 3 divided by 2, 24. That's going to be 12. Perfect. So when m equals 3, 27 minus 3 times 3, right? It's going to be 18. That's going to be 9. Then the last, not the last one. So yeah, you will get all the solutions. 3 times 5, 15. 27 minus 15 is going to be 12. It's a 6. Then the last one. 27 minus 21 is 6. So it's 3. So indeed, we get, here we got 4 solutions. Okay, it's a pretty similar idea. You only have a few cases to check at the end. You cannot check all of them, but you have to really need to make some observation then you conclude that n must be odd. Okay, then you don't need to waste time to check other terms. So check all the other cases. Okay, so those are the, it's about polygons and the corresponding equations in number series. Okay. About the polygon, I need a, I'm going to have a question to ask you. This is a question. So I have a rectangle, okay? This is a rectangle. Okay. Then I choose a point. This is 45 degrees, some points here. And here's alpha, this angle is beta. Okay. So when this point P moves, okay, alpha beta changes. That cannot be uniquely determined. Right. My question is, what is the value of alpha plus beta? Can you determine that? Okay. Maybe the answer is cannot be uniquely determined. Okay. So there are a bunch of, you can even find the orbit to make sure, so they always have a 45 degree. You can, right, this angle. So alpha beta changes, but all I have to make sure is the angle is 45 degrees is unchanged. Okay. So what is the value of alpha plus beta? Think about this. Yeah, this is just a review of the formulas we learned, Yes. It's 45 degree, right? So to solve this problem, you just needed to look at this polygon. Okay, here's alpha, here's beta, here's 45 degree, and that is the interior angle. The interior angle is 270 degree. Okay, so the sum of these angles, okay, is going to be 180 degree times 4 minus 2 because n equals 4. So it's going to be 360 degree. That's the formula you're going to use. Then alpha plus beta is going to be 360 minus 270, which is 90. 90 minus 45 is going to be 45. So that's always a constant. Okay, that is always a constant. Okay. All right, so my next question is a little bit strange. Okay, so I have a circle because it requires more information. This is a center. Okay, I have a, I draw the points here. It's not necessarily exact. Yeah, so this is going to be picture. Okay. So these two angles are going to be identical. Okay, it's possible, right? Yes. And do you think if I shrink the circle, alpha will change or not? That's my first question. Yes or no? That's huh? You don't think so? Okay. But if I move those 2 points right away, right, that changes alpha, right? So I'm going to put the beta here. Okay. So if alpha equals 30 degrees, what is beta? This is a special polygon, but it's inside the circle. And there was one point at the center, as the 3 points on the side of the circle. 60. Edward, do you have answers? You do need a additional piece of information about this polygon because it sits inside the circle. It's not arbitrary. Okay. A circle inside, and this is a beta. Okay. Actually, you can determine this angle. It's the interior angle. Okay. And this is a 30 degree alpha, right? Let's put alpha here. Okay. So we remember this is going to be 2 beta. Okay. So that will be 360 degree minus 2 beta. So the sum of the interior angles will be alpha plus beta plus 360 degree minus 2 beta. Okay. This is a 4 polygon, right? It's going to be 360 degree. Yeah, 4 minus 2. Yeah, it's a 360 degree. So 360 degree canceled out, right? And then beta equals to alpha. Okay, so it's interesting. Beta equals to alpha. Okay, and they are all related. Yes. So that's going to be 2 times 30 degree. It's a 60 degree. Yes. That's how do we get this. So we need if we are given the polygon in some circles, there is additional hidden information there, which you have to use that. Otherwise, you're not figured out. You cannot figure it out to answer. Okay. Well, our next topic is about coordinate system geometry, right? Coordinate geometry. Coordinate geometry. So that means we describe figures in the XY coordinate system. Okay, Y and X. And sometimes we are given the information such like if a triangles. Okay, so this is 0, 0. Remember this, right? Let's do this first. And here is going to be the 4 and the 4. And that will be, let's say, 6 and the 2. Make arbitrary. So A and the B and the C. My question, first question, what is the area of the triangle ABC? Right? We know 2 formulas for just for the area triangle, right? It's height times the base. That's the simplest formula. But Yeah, but it's not very useful in some cases, like a B, right? So area is going half of BH. Everybody knows that. There's another formula. If you know A and B and C, it's called Heron's formula, right? It's going to be S minus A, S minus B, S minus C. And the S here is half of the parameter. That's also one formula. So if you know the three sides, but that's not the way we cannot use any of these formulas to figure out the area of that region. Okay, so we're not able to get that region, area of that region. So how do you do that? You still use the area of triangle to solve that, but that's give me 4 and the 4 and the 6 and the 2, right? Let's redraw the picture. Okay. So you need to draw addition lines to figure out the area of triangle. Okay. So how do you do that? You draw a rectangle. Okay. You draw the rectangle. That's my hint. Then, in order to find the area of this triangle inside rectangle, you can use, but this is very irregular shape, right? You have to use the subtraction method. So you got answers? 8. Okay. Yeah. So what you do that, in order to find the area of triangle, you find the area of those triangles first. Then you subtract it from the area of this rectangle. Okay. So the area is going to be the area of the rectangle, which is the height is 4, the length is 6, minus the area at the bottom. The length 6 times 2 minus from 2 to 4 is 2. From 6 to the 4 is also 2. And then the height is a 4. And the length from 1 to, it's a 4, right? So you just do all the calculations. It's going to be 24 minus 6 minus 2 minus 8. Okay. So that is going to be 8. Okay. So 8 is the answer. It's integer. But if you really want to find the 3 sides of the triangle, you can use a distant formula. But it's a little difficult because this is a 4 and that's a 4, right? 4 square plus 4 square, it's 4 square root 2, right? And here is 2, 2, and it's 2 square root 2, right? And this side is 2, that's the side 6. And so then you calculate this, right? 2 and 6. 40. So it's 2 square root 10. You see, if I give you the triangle with the 3 sides, how do you find the area? It's very complicated. You have to use a Heron's formula. Then you have 3 sides, and still, yeah. Then you simplify. I'm not sure you're able to quickly get 8. Okay, so that's the first. Okay. But our next problem is, you're probably familiar with that. A couple of students have problems. Okay, it's going to be here, -4 and 2. Okay, and that is going to be 1 and 2. And that is, I'm trying -1 and 5. Okay, so I have a triangle. It's easy to get the area, right? Yeah, -1 and 5. -1 and 5. Just we'll give it this. Yeah. Okay. Now, when you refract it above the x-axis, above y-axis, right? What do you get? This point goes to here, right? That's the triangle, the mirror image, right? About, yeah, this will be 1 and 5. That'll be 4 and 2, right? And then here will be -1 and 2. So the question is, what is the question? Area of the intersection, right? Yeah, area of the intersection. Now it looks, as long as you draw the picture, then it's clear to you, right? You get a smaller triangle. All you have to do is to figure out the intersection point, this point. Okay, yeah, this is the coordinates of that point. If you can do that, then you can figure out the height of the triangle. This is an isosceles triangle, right? So what is the area of the intersection of two triangles? Okay. Yeah, two triangles. Okay. So yeah, you have to. You have answers? Huh? 1.5. You see, let's look at the slope of this line. Okay, let's look at the slope of this line. Maybe we can easily get it. The slope of this line is the difference of the y coordinates, right, minus the x coordinate, divided by x coordinate. So it's 3/2. The slope of this line. Okay. So if we know the slope, then you can figure it out using the slope to figure out the intersection point. This intersection point is 0 and the b, right? So this is also equal to b minus 2. 0 minus -1. 0 minus -1. That's useful, right? So 0 minus 2 is 1. So it's b minus 2. So the y-intercept, without finding the equation, linear equation for the line, I can figure out the value of the y-intercept. So b equals 2 plus 3/2 and 7/2. 7/2 is the coordinate of the intersection point, but that's not the height of the triangle. The height of the triangle is still 3/2. Okay. Yeah, the height of the triangle is still 3/2. So the height h is 3/2. Okay. The base, the length is going to be 2. So the area is going to be half of the base times the height is going to be 3/2. So 3/2 is is going to be the answer. Okay. Yeah, just be careful when you do the computation. You know, you need to find the height of the triangle. Okay. Just use a slope. You can determine the height of the triangle. Okay. And another, you don't need to find the intercept even, because if you know this is right, if you know the slope is 3/2 and this side is 1, the other side must be 3/2. Okay. Yeah, because h/1 is going to be 3/2. So that implies h is going to be 3/2. If you have a triangle like that, if you know the slope of this other side, it's 3/2, and that implies h must be 3/2. Okay. Yeah, we go back to the, let's look at the this problem here. Yeah, I'm going to use the same equation. And here -1 and the 5, -4 and the 2, 1 and the 2, okay? So what is our project? Our project is we're trying to cut this triangle into two parts of an equal area. So, but it must passing through this point, okay? So this is a line going through that, right? So it's a, let's see, yeah, find the the slope of the line, right? Such that it divides the triangle into two parts of equal area. Right. To to solve this problem, equal area, you probably can figure out the equal area because the height of the triangle is 3. 3, the base length is going to be, yeah, it's a fraction, okay? So from -4 to 1 is a 5. From 2 to 5, 3. So the area of the triangle here is going to be half times 5. 5 times minus, it's a 3. So 15 over 2. So the half of the area will be equal, yeah, equal parts of area will be 15 over 4, right? Divided by 2. So then you just justify the slope passing through that point. That is a point that's going to be 0 and 2. Okay, so definitely this line will below the point with coordinates -1 and 5. Why? Because if we passing through that point, and you get right hand side of the triangle have a small area than the left hand side of the triangle. So it must be a little bit lower other side, okay, below the point. Okay, clear, right? So the question is, what is the slope and how do you determine the slope? All right, so to do that, I think we just needed to know you assume the equation, right? The equation has a slope, so y minus y equals k times x, right? But this should be equal to 2, okay? Yeah, that's the general form of the equation. So you determine the value of the k. And if you're able to figure out the y coordinates of the intersection point, then you can tell the height of the triangle. So how about the line of the equation of this line? The slope here is going to be 3 over, right? With the slope, right? The slope is going to be 5. We did that before, right? 5 minus 2, and the -1 minus -4. It's going to be 3 over the difference of the y coordinates, right? The difference of y coordinates, and the 5 minus 3. Then the difference of the x coordinates, it's also given 3. It's actually is 1, right? The line of that. So actually, you wanted to find the intersection point, y equals kx plus 2. That is an unknown line. Other one, you already know that because you know the slope. Okay. The other one, you know the slope, right? Slope is 1, right? Y minus the difference in y variable is 3. The difference in x variable is 3. So the equation would be y minus 2 equals 1 times x plus 4. Okay. So you just need to solve for the y variable because that's all you needed to know. You don't need to know the x variable. So let's look at the y variable. From the second equation, the x variable is going to be y minus 6. And you put into the first equation, okay? Then you solve for y, okay? So you get ky minus 6k and plus 6. So what you get is 1 minus k equals 2 minus 6k. Then you solve for y. Okay, so that is the y-intercept. If you know the y-intercept, you know the height of that triangle. The base is 2. So the area of that triangle, yeah, if you look at this picture, right? So we are doing here, right? So this is here is 4, right? And the height h is going to be y variable minus 2 because this is yeah. So the height is going to 2 minus 6k minus 2. So that is the height, okay? So once you get a height, you get base. So the area of the triangle is going to be half of 4 times the height, okay? And that's supposed to be half of the whole triangle. That's going to be 15 over 4. And the equation is a little bit complicated, but you can eventually solve it, okay? So you can multiply by 2, and that's going to be 2, right? 2 times 1 minus k, and 6 minus 2 plus 2k, okay? And then what do you get? You will get 2 canceled out. It's just negative 4k. Okay. All right. So you do the cross multiplication. So 16 negative 4 times 4, 32k, 15, 1 minus k. Then I move this term to the right-hand side. I will get, oh, what I get? 17K, right? Right. All right, this is a little bit strange numbers, but that's the solution. K is negative. Okay. But the idea is simple. You, I did not carefully choose the numbers. That's the reason I get involved fractions. So the idea is simple. You just need to determine the slope. Then you determine the intersection point. The y coordinate of the intersection point is going to be the -2 is going to be the height of the triangle. Then you take the area of the triangle. All right. Now, so we finish the geometry problems. I'm going to focus on the number series problem. Okay. Our next problem is about a bunch of numbers. You will see that this is a cube, right? It's not the cube. The numbers will be from the cube has numbers from 1 to 6. Okay, they are listed. Let me briefly mention the problem. So that's number 20. 25. So this cube, all the numbers are different, okay? And this is the numbers from 1 to 6, okay? But they're expressed the expressions are, the numbers are expressed in the following form. So a plus 1, 2a minus 5, 3a minus 10. We also have a b plus 8, 2b plus 5, 3b plus 10. 3b plus 10, 2b plus 5, 3a minus 10. That's right. So b plus 8. So we're trying to find out the values of a and the b. Okay. Find the a and the b. Now what we know is all the 3 numbers are different. All the 6 numbers are different. First, second, they're from 1 to 6. Okay, from 1 to 6. Now, what is the best way to solve the problem? It's too complicated, right? But 3 different numbers here. First of all, what you do is you add all the numbers together. Okay, if you add all the numbers together, that's the first thing you do, right? And because we don't know their order. Okay, then we don't know their. If we know a plus 1 is 1, that's okay. Then you already determine a, but we don't know the order. We only know those 6 numbers are expressed in 6 different forms and in 2 different variables, a and b. So the first thing I can try is just add all the numbers together, okay? And I think it'll make it easier. So it's going to be a plus 1 and 2a minus 5, 3a minus 10, and plus b plus 8, 2b plus 5, 3b plus 10. Okay, so you will see all of them canceled out. How many a's I get? I get 6a, 6b, and I get a 9. Okay, but I know it's 1 plus 2 plus 3 plus 4 plus 5 plus 6. All of those numbers adding together. What is the value of this? 21, right? Yeah, because this is a 10, 5, 6, 21. So 6a plus 6b is going to be 21 minus 9, 12. And then you will see that a plus b have a very simple relationship, just 2. Okay, that's good. Okay. So once you determine A, you can determine B. So essentially, there's only one variable there instead of two. Okay, so you can assume, you can assume, you can do like that. You can solve for B in terms of N and list all those numbers again. Okay, I'm going to write, okay, B equals 2 minus A. I'm going to put into, first of all, I have this, right? 3A minus 10. Then B is going to be 2 minus A, so it's 10 minus A. And the 2B plus 5 is going to be 4 minus 2A plus 5. So it's going to be 9 minus 2A, right? And the 3B is a 3B, 3 times, so 6 minus 3A plus 10. So 16 minus 3A. So now you just have those numbers expressed in terms of A only. Okay. In terms of A only, then you can quickly determine. The possible values for A. The reason is, think about that. Your number is always between 1 and 6. Okay, 1 over 6. So you look at those numbers. I think A cannot be smaller than 4, right? A cannot be smaller than 4. Which one tells you this? Yeah, let's look at this, right? So 3A minus 10 should be greater than 1. Okay, 3A, that implies 3A is greater than 11. That implies A is greater than 11 over 3. So clearly A should be greater than or equal to 4. The reason is A is integer, okay? A is integer. So now, but if A is too large, then you have a trouble, because if A is a 5, 5, right? Then you have this problem. Just quickly determine, right? If A is 5, 9 minus 2 times 5 is already negative. So the only choice is 9 minus 2A should be also greater than or equal to 1. So that implies A, 2A is going to be, A is less than or equal to 4. So there's no choice. So A should be equal to 4. Then you double check. It's okay or not. Otherwise, if it's not okay, then no solution. So you write down all the possible numbers. 5, 2A minus 5 is a 3. 3A minus 10, 3 is 12 minus this 2. 10 minus A, 6, 1, 4. Great. So we make it. So indeed, this is a solution. Okay. Indeed, this is a solution. Yeah, there was, you have to be careful using those encoders to figure out. Like in this case, that's a unique solution. Okay, you can sometimes you get a solution for A, you get right, then you check that, find out there's some you're never able to get 6 different numbers. Then the answer is no solution. Cannot just stop there. Oh, A equals 4, then put the 4 there. Maybe the answer is no solution. Okay. Yeah, but for problems on the string run, there's always a definite answer. But for targeted run, and the answer will be not definite. It's not like I always get a number. Sometimes the answer is no solution. You have to show the details. You are given 3 minutes to do the problem. Okay. So we look at another problem, which is pretty similar problem. Always involves 6 numbers. This is problem number 18. Okay, so let's take a look at this one. How do we analyze it? So we are set of 6 distinct integers. Okay, so all the 6 numbers. Okay, a set of 6 distinct positive integer. Okay, the mean is going to be 8. Okay, a median. The median is also going to be 8. Okay. So the question is no terms greater than 13. Okay. And what is the largest possible value of any numbers? What is the least possible value for any number in this set? So what is the least possible numbers in among the 6, basically? Of course, you have 6 numbers that cannot be too large. All of them less than or equal to 13. So it's what is the least possible numbers, right? Among them, right? Okay. So what you do is you can list them in the order. I'm going to say A1 less than A2, less than A3, A4, A5, A6, and this should be smaller than 13. My guess is if you see a problem like that, it's possible. It's possible A1. We are looking for A1, right? It's possible A1 can be 1 or 2. So yeah, there's not many choices there. Okay, because all those numbers, 6 numbers, they are not larger than 13. Okay, so first thing you have to do is you add. What does it mean? You have to use those conditions, right? A1 plus A2, A3, A4, A5, A6. The sum is going to be 6 times 8. Okay, 48. Otherwise, the mean is not going to be 8. Another thing is the median. Okay, so it's 8. What does that mean? That means A3 plus A4 divided by 2 is 8. Okay. Yeah. So one number is larger than 8, another number smaller than 8. Okay, so add them together, they are. So using those conditions, I want to make A1, A2 as small as possible, and so A2, A3, this part is going to be 16, right? So basically, you have 16 here, A5, A6 equals 48 minus 16, 32. Okay, so that's missing here. You deleted this part. So you only have 4 integers. Okay, those 4 integers. In order to make A1 as small as possible, you have to make A3, A5, A6 as large as possible. So you already given the upper bound. So I would like to choose 13. And I just by guessing trying, okay? If I can make it or not, right? So this will be 12 maybe, for example, okay? Then the rest of them is 25, right? 13 minus 25, which is going to be 7, right? 7. Okay. So 7. So 7. How do you make it, right? 1 plus 6. Okay. If impossible, you make it smaller. 2 plus 5. Depends on how do you put the two numbers in the middle. There's enough space for the two numbers in the middle. The sum is going to be 16. One should be less than 8. Another one should be larger than 8. Because, right? So when it's 7 and when it's 9, I think it's fine. So you can 7 over 9, okay, and the 9. So still it'll be 18. That works. This is a way how do I think. If it's a 6 over 6 and 10, then all I have to do is justify, make sure this should be less than 7, right? And then I change 6 to 5, then the other number must be 2. Okay, so that's the idea to figure it out. So 7 is fine. Then the next number, A2 should be equal 6. Then you can make A1 to be 1. Okay, 1 should be, no, 1 definitely is the smallest number. Okay, 1 is the smallest. So just step by step and simplify the problem. Okay, otherwise it's harder to guess and try. You know, when you get the equation of only 4 numbers, right? That's the equation A1, A2, A5, A6. Then much easier to handle. Okay. Okay. Then you can try A6. Sometimes A6 cannot be 13, maybe just 12. Then just try different ways. Yeah. But luckily we get an answer. Okay. All right. Let's see the next problem. I'm trying to go over the. Yeah, I'm trying to go over this coordinate geometry. Let's go back to this. Okay. So the last problem, we want to find the value of the case for which these two linear equations, okay, will not have a solution. Okay, so we have a 6x plus 4y equals 7, and the kx plus 8y equals 7. Now, what's the geometric meaning of this? If you have coordinate system, right? So the slope, it looks like that. So this is a line like 6x plus 4y equals 7. Okay. Another one, it says that has no solution. No solution means there's no intersection point. Okay. So I cannot draw the other one because I don't know the value of k. But the when you the key point is two lines. Yeah, when we say two equations has solution, means they have the intersection point of these two lines. Okay, two linear equations corresponds to two lines. Two equation has a common solution, means two lines intersect somewhere. Okay, so if you look at two lines, when they intersect, when they're not, if they're not parallel, they intersect each other. If they're parallel, they do not. If they're separate. So yeah, that means those two lines are parallel. Two lines must be parallel. Parallel really means they have this, right? Having the same slope. Okay, if they do not have the same slope, they intersect. Okay, that's the geometry there. They have the same slope. Okay, now how do you determine the slope of the line if you know the equation? Okay, if you have ax plus by equals c, okay, then you simplify, you get y equals mx plus another number, right? Plus, let's say plus d. So whenever you, if you rewrite the equation into this form, that is going to be the slope, because this coefficient is going to be slope. Okay, so now you have two equations. Okay, you have two equations. 6x plus 4y equals 7. So that equation, if you solve that, it's going to be negative 3 over 2x plus 7 over 4. We don't need to care about this number, right? We also have kx plus 8y equals 7. That implies negative k over 8x plus 7 over 8. Now, those are two lines with a different slope, y-intercept, right? And have a different slope at this moment. So they are parallel. Yeah, they are parallel if and only if negative 3 over 2 equals negative k over 8. Right? So how do you solve it, right? K equals 3 over 2 times negative 8 and 12. So k should be equal to 12. Okay, so that's the review about the coordinate geometry and how we, yeah, we have a line and equation and the coefficient. The geometry mean of the coefficient of the equation will be slope and the y-intercept. Yeah, that's all about today's class, and you are going to get a homework assignment. Please submit the problems you have some trouble before the midnight of September, Saturday. Okay.